Hello, welcome. Let us start our fifth lesson of statistics. Today, we are going to talk about the topic frequency distribution. Once again, at the end of the class, we will have fun practical examples provided in Excel and Python. We have talked about frequency before, if you remember, and in simple terms, frequency in statistics is how often something happens. Frequency is tied to observable phenomena. It is how many times a categorical or numerical value appears in the data, such as how many times different people read the book Moby Dick. Albert read the book 3 times, the frequency is 3. We can examine other frequencies, such as the frequency for John. John never read the book, so its frequency is 0. Arthur read it twice. The frequency in this case is 2. In summary, frequency allows us to examine the distribution of values within a dataset. So far so good. But then, what is a frequency distribution and when should we use this term? From a mathematical point of view, a frequency distribution is a function which, for every occurring value, states how often this value has occurred. The function maps each individual value to the number of times that the value has occurred as an outcome, as an observation. A frequency distribution can be represented as a table, which we call frequency table, or as a graph, which we call histogram or line chart. As a note, consider that it is frequent to see people using the terms of frequency distribution and frequency table interchangeably. Note that they are different. Briefly, a frequency distribution is a mapping from the set of results to the frequency domain. In contrast, frequency tables or histograms, as well as any other suitable graphs, are representations of this concept. Today, we are interested in how we can represent the concept of frequency distribution, either using a frequency table or a graph. Last lecture, we have talked about frequency tables and we saw how to apply them to categorical data. But what if I told you you can apply frequency tables also to represent the frequency distribution of numerical data? Let us investigate this. A frequency table is used to organize collected data. What data? Well, the data could be anything really. The data could be categorical or numerical. In this lesson, we will focus on numerical examples since we have covered categorical data previously. A list of examples of numerical data include the heights of basketball players, the daily Bitcoin trading volume, the daily calorie consumption, the temperatures of different cities, and others. After data collection, we can obtain a longer or shorter list of values. For example, we can collect the time spent on social media for John Smith during a month. We will collect 30 values corresponding to the 30 days, for example. This volume of data is already significant and difficult to analyze. To guarantee a good understanding of the data, we must show the data in a meaningful manner. We need to organize the data in such a way that it is summarized. For this, we can use a frequency table. Remember the concept of frequency table? A frequency table can be defined as a tabular method where each part of the data is assigned to its corresponding frequency. Let us talk more in depth about frequency tables for numerical data. Let us see an example. John lives in a not-so-busy street, and his son likes to count the number of passengers in the cars passing by. In 1 hour, he annotated the following values. Let us represent this data in a frequency table and find out the frequency distribution of the data. A frequency table is constructed by arranging collected data values in ascending order of magnitude with their corresponding frequencies. We have a list of 4 values: 1 passenger, 2 passengers, 3 passengers, and 4 passengers. These values we designate as the classes. A class in statistics is a grouping of observations with the same characteristics. In our case, we have 4 classes, from 1 passenger to 4 passengers. In our example, it is the number of cars that were recorded as having a given number of passengers. Before we proceed, it is advisable to talk about tally marks, a technique used to help calculate absolute frequencies. Tally marks are the representation of the data in the form of vertical lines. We put one vertical line for each of the 4 counts. A diagonal line is put for the 5th count. In our example, the car with the identification of 1 contributes with 1 tally mark for 1 passenger, while the second car contributes with 1 tally mark for 4 passengers. The third car contributes to 3 passengers, and so forth. To construct frequency tables, the tally marks can be used to keep track of the frequencies. We translate the tally marks to absolute frequency values in the last column. Now we have a complete description of the frequency distribution. We can see that all the collected data is organized under the column number of passengers and under the column named number of cars, which is our frequency column. This makes it easier to understand the given information. We can understand how many cars had the lowest number of passengers, for example, or how many cars had 4 passengers, which in this case was just 1. This and other information can be obtained from the table. Thus, frequency tables in statistics helps us to organize the data more straightforwardly. There are 2 major types of frequency tables according to how the data is grouped: ungrouped frequency tables and grouped frequency tables. When you are summarizing small values of data, then it is better to organize and represent it as an ungrouped frequency table. This is a type of table that shows how many times each individual occurs in a dataset. These tables are usually used to calculate the accurate frequency of individual data values. For example, if you consider the number of scores in a professional soccer match, we have a small list of classes. Or say you are interested to know how many plants people have in their homes. In this second case, the list of classes is also small. Let us see this in more detail with an example. A survey was taken on Oxford Street. In each of the 20 homes, people were asked how many domestic animals they took care of. The results were recorded. We will follow the next steps to present this data in an ungrouped frequency table. Step 1. List the set of possible values and then count the number of results for each individual value. Step 2. The third column is the relative frequency column. Here we add the relative frequency of each row. The formula is frequency divided by the total number of observations multiplied by 100. The relative frequency column determines the proportion of the total number of observations associated with each class. Step 3. The fourth column is the cumulative frequency column. You must add one value to the next, then add the sum to the next, and so on until the last value is reached. The end cumulative frequency will be the total of all frequencies. In the end, you will obtain an ungrouped frequency table with several columns. We use this table for data that is discrete with a manageable set of classes. Let us now look at an example of how to make a grouped frequency table. It is like the previous table with slight differences. In contrast to ungrouped frequency tables, grouped frequencies tables considers data into groups of data values. We designate these as class intervals. Using class intervals is a way of organizing a large set of data into more manageable groups. Consider that we surveyed the age of customers in a pharmacy for an hour. We obtained the following data. How can we establish class intervals for this example? We can simply create 10 classes, 1 to 10, 11 to 20, and so on, until 91 to 100. What is the frequency in this context? The frequency of a class interval is the number of observations that occur in a particular predefined interval. For example, we can see that we have a frequency of 2 for the class 0 to 10. An important concept for grouped frequency tables is that of class width, which is the difference between the upper class limit and the lower class limit of a class interval. What does that mean? In our case, we have a class width of 9, since the difference between 10 and 1 is 9. Note that interval classes need to be mutually exclusive and collectively exhaustive. This means that the class intervals should not overlap. Notice that we carefully define the intervals without overlap. They cover all the values also, meaning that they are collectively exhaustive. Let us see this in more detail with another example. At the recent chess tournament, all 10 participants had to fill out a form that gave their names, addresses, and age. The ages of the participants were recorded. We follow several steps to present this data in a grouped frequency table. Before proceeding, please take note on the following steps. Step 1. Divide the results into intervals and then count the number of results in each interval. In this case, intervals of 9 are appropriate. Since 36 is the lowest age and 92 is the highest age, start the intervals at 35 to 44 and end the intervals with 85 to 94. Step 2. Create a table with 5 columns. Frequency distributions can be visualized by frequency tables or by graphs if the data is either continuous or discrete. If the data is discrete, a bar chart with non-connected beans is appropriate. By adding gaps between bars, you emphasize the fact that the data is discrete in value. If the data is continuous, it is better to use a histogram. A histogram is a graph that shows the frequency or relative frequency distribution of a quantitative variable. It looks like a bar chart but without gaps between the beans. Numerical data, either grouped or ungrouped, have more forms of representation. We will see this in the next lecture. Let us now see some fun practical examples provided in Excel and Python. Let us start with Excel. We can use Excel to create and organize data in frequency tables. In this first example, we will explain how to create an ungrouped frequency table. In the Excel, we have the number of children in British families. Children here is defined as any person with less than 14 years old. In the list, we can see that some families have 0 children, others have 1 child, others have 2 children, and so on. No family here has more than 5 children. With this data, we can create a pivot table and then change that table into a frequency distribution. To do so, highlight the data. Then click the Insert tab, then click the Pivot Table icon. In the Pivot Table panel that appears on the right side, drag Number of Children to the Rows box. Then click the drop-down in the Values box and click Value Field Settings. In the new window that appears, click Count in the menu and then click OK. If you want to add a relative frequency column, you need to drag the variable number of children to the Values box. Then click the drop-down arrow, select Count and then click Show Data. Here, please select the option of percentage of grand total. To add cumulative frequency, you just need to follow the same procedure, but now select the option of percentage running total in. In a second example, we will list the steps to create a grouped frequency table. The easiest way to create a frequency distribution in Excel is to use the group feature with pivot tables. Suppose we have the following dataset in Excel that shows the weight in kilos of different adults. Suppose we would like to create a grouped frequency distribution table for this dataset. First, we select the data. Then we select pivot table. Then we change the columns. And voila! Finally, we will see a simple example in Python. A method that you can use is the value count function, which will return a count of unique values in all series. The result will be in descending order, which implies that the first element is the most frequently occurring element. Thank you for watching and see you next video.